This video is just a continuation of the methods for solving trig equations from exercise 2e, in that now we're going to look at the second method, which is called the t formula. So we looked at the concept of introducing t as a parameter, and this method for solving trig equations now is based on that concept of introducing t as a parameter. We'll have an equation in terms of t to solve, and then we will replace our values for t with our tan theta on 2, as you know. This method would also be used when the equations look similar to those that we had in with the previous method, in that the equations will look like something with a sine theta or x plus b cos theta or x is equal to a constant. Now, I find that most questions will actually request that you use the t formula, because if you think about it, if you just had an equation in that format, you've got a choice now of using the auxiliary angle or the t method. And depending on which one you end up liking the best, you would use those. So if the marker wants to see if you understand this method, which you must be able to demonstrate you can use the method, they might direct you to this particular method. If you choose to use the method, even though it's not suggested, you need to be careful, and I've covered that here. If theta is 180 happens to be a solution, it will not be found using this method, because if we think about it, if theta is 180, we know that tan of 180 is tan of 90, and we know that tan of 90 is undefined. So you won't ever get theta being 180 using this method, but it could possibly be a solution. So that's just something to be aware of. Certainly if you're instructed to use this method, this is not going to happen. Okay, so in general, only use the method when instructed to. We know, and it's written on the formula sheet, that if we have an understanding that t is tan of theta on 2, then we've got some expressions for tan theta, sine theta and cos theta. And then I'm sure you can see that sine theta and cos theta in this format of being expressed in terms of t could be substituted into this equation in place of sine theta and cos theta, and we would create an equation in terms of t and be able to solve it with respect to t. So that's exactly what we do. So it says the trig equation is replaced with an equation involving t. This equation will often be quadratic. Be aware, if it comes up as a linear equation, it's possibly heading to this situation where a possible answer for theta, or x, is 180 degrees or pi radians, and you would need to always check that. Just one more thing, you won't actually get that solution out of using the trig equation, so you will need to test it, I guess, because it wouldn't be obvious. So let's have a look at this example. 3 sine x minus 4 cos x is minus 2 for x between minus 180 and 180 degrees, using the substitution t is equal to x on 2. So we know that we've got this connection between when we've got sine and cos of x degrees, and as we have here, sine of x, cos of x, that we can replace with, considering tan of x on 2 being t, we can replace the whole of sine of x with 2t on 1 plus t squared, and all of cos of x with 1 minus t squared on 1 plus t squared. So you can see I've started to do that 3 times the expression for sine of x, and I've gone on and substituted for cos of x, which then, completing the equation, gives equal to minus 2. You can probably see already there that we've got an equation in t, and then it's a process of simplifying that equation and solving. So the subtraction of fractions means we need a common denominator, and in this case subtract the numerator and simplify your numerator, cross multiply, bring all terms to one side, divide both sides by 2, identify your a, b and c, use your formula, minus b plus minus square root of b squared minus 4ac on 2a, and then we've got that, simplifying that, we've got that t is equal to minus 3 plus root 21 on 6, and I just wrote that as 3 on 6, which is minus a half, plus minus the root 21 on 6. So we know that tan of x on 2 was t. One of the options for t is this one. And if tan of x on 2 is that, then x on 2 is tan inverse of that. And I just went to the calculator for that. Get that x on 2 is that, therefore x is 29.6 degrees. Then the other value for t, taking the negative a half minus root 21 on 6, gives x is negative 103.29. That really wasn't all that nice, actually. Doable, but not nice. I think I'll leave this second example and do that one with you in class. So for now, you might be able to get started with some of the questions from the latter part of 2E, say out of question 11.